Okay, hello everyone. So it's lecture number 2 for Introduction to Programming. And as I promised last time, while the first lecture was mainly about the practicalities of the course, today we're going to concentrate on actual programming. Uh, and I'm hoping that you all have completed as much as week 1 as possible, because that's where we're going to continue. And today uh, I will be using this editor called Visual Studio Code, which looks like this. Uh, and when I execute the program in VSC, it shows the output in here in this console. There's some other stuff as well. It shows the path of the Python interpreter and things like that. But here is the output. And this is the same editor you will be using starting at week 4. So as I mentioned the last time, the first 3 weeks you can complete by using your browser only, but then starting on week 4, you're going to need to use the external editor. And Visual Studio Code it's a really uh, uh, quite popular editor. It's also sort of a professional editor in a sense that it's used a lot in the industry, and it's really easy to use, but it's also really there are a lot of features for advanced users as well. We can maybe talk about a little bit more about it on week 4, but there are really good instructions on how to install it and how to install the TMC plugin. Anyway, I will be using this in this lecture. Before we start with the programming, a couple of things. Last week we covered these topics, or you basically went through these topics on your own. So we started by outputting the data using the print statement, and then inputting data by using the input function. uh, you practiced using variables, which are really important feature in almost any program. Whenever we are writing a program, we need a way to store and manipulate data, and variables are basically used for that. Then we talked about, or you, we didn't really talk about, you practiced reading integer type data, which was a little bit different to reading strings with the input function. We still use the input function, but then we need to use the int function to convert the strings into integers. Then a little bit about formatting output, about outputting both strings and integers with the same print statements. We're going to talk more about formatting output in the upcoming lectures. Uh, Things like f strings and things like that, but let's save that for the future. And then the first week was concluded with simple conditional statement, and this is basically where we continue today. I went through some of the questions you were asking in different forums. One was that do we have a Moodle page? I think there probably was an information somewhere that all the courses have a Moodle page. We don't. So the material page in programming -24.mooc.fi is the only material we'll be having. Everything you need is right over there. So there's no Moodle in use. Okay, I think that's pretty much the main question for the first week. If you have any other questions about practical things, you can ask them today as well. Just go ahead whenever you feel like it. Again, I remind you that if you type questions to the chat window, they are not visible in the recording that's published. So you can do it without thinking that everyone will see your question. I will read the question out loud, but not your name. Uh, you can use your microphone if you want to, but if you use your microphone, then it's recorded in the recording, or then you can hear it on the recording as well. So I think I sort of prefer if you use the chat window. It's easier for everyone. But I'm just saying that be aware that if you're using the microphone, then it's on the recording, and we will use it without getting any additional permissions. Okay. Uh, a couple of words about programming terminology again before we go to actual programming examples. These are the kind of terms we will be using throughout this course and the next course, the advanced course as well. These were mentioned in the first week's material already, and I think it's important that you start to familiarize yourself with these terms already. There's a question, is it possible to download the VS Code before part 4 to try out coding? Yeah, definitely. If you just Google for VS Code download, you get to the download page and you can do it. You can do it with no problems. It's free and it's easy to install for into almost any operating system. So go ahead. You can install it before week 4 if you want to try it. And I think it's a great idea if you do. If you want to try some like additional coding, that's always a great thing. But back to terminology. So some of the things already mentioned are were the statement, which is like pretty much like the statement in a natural language. So it's one single sort of part of a program that executes something, like the print statement, which basically outputs a message on screen, or the if statement, or assigning a value into variable or something like that. Uh, then the blocks were briefly mentioned, and we're just going to talk about blocks more today. But block is a part of a code indented similarly that belongs together. Expressions are something that the Python can evaluate and that result into a value. Functions are something that can be called and again return a value, like the input function, which returns the value typed in by the user. Again, we're going to talk more about your own functions later. Types are important thing in Python. Python is a dynamically typed programming language, meaning that we don't need to define the types ourselves, but all the variables still and all the objects still have types. So you may have a type that's or a variable that contains an integer type value, and that sort of defines what you can do with that variable. Or if you have a variable that contains a string type value, then you can do different things with that variable, and that affects the result of expressions and things like that. Then debugging is a final term. Well, definitely not the final term for this course, but final term for today. Uh, and what we mean by debugging is that we test our programs and try to locate the errors in our programs and then fix those errors. And debugging is something that's really important, and it's sort of an essential part of any programming process, because making errors is really it's sort of, how should I put this? It's really like a really important part of the whole process, because it happens all the time. It's really uncommon that you write a program, especially if it's a bit more complicated program, from scratch until it's finished and don't make any errors. So it just works, and that doesn't really happen. And and it's really typical that even if you're an experienced programmer, you keep making errors, and then you detect those errors and fix those errors, and you test your program until you're sure that it works as intended. Uh, and there are, again, we're also going to talk more about debugging later. There are tools you can use for that one, or tools that can help you with that one. But for all these first programs, you can usually sort of debug them by just going through the code and then asking someone if you can't locate the errors yourself. Okay. So let's see what we learned last time. So the programs we wrote were something like this. So we queried the user for a value, like let's say a number, and then we wanted to find out that if the number is, for example, larger than 1000, and then we can display the message that the number is quite large or something else. And then let's say the program ends here at the end. So how this program works, if I execute it, it queries the user for a number. If the number is smaller than 1000, like 500, then it just displays the end message. But if I re-execute it and I enter a number larger than 1000, like 1500, then it states that the number is quite large and the program ends here. So at the end of part 1, we discussed the conditional statements. And the idea of a conditional statement is that this code block here is only executed if this expression is true. And there can be number of statements in a code block. It isn't reserved in Python. There actually needs to be at least one statement in Python's code block. So it isn't a code block if there are not any statements, but the number isn't really restricted in any other way. So you can have any number of statements in the code block, and these statements in this block following the if statement are only executed executed if the condition is true. There's a question in this case: what if the number is 1,000? What if the number is 1,000? Does it execute this code block on lines 4 and 5 if the number is 1,000? Exactly 1,000.
No, it doesn't.
Sorry, I didn't get it. Yeah, you're absolutely right. It doesn't execute because the number needs to be larger 1,000. There was also a question: why don't you first make a condition equals number larger than 1,000? We're going to talk about that a bit later today. That's a good question. Okay, so anyway, we can do a lot with these if statements and conditional statements, and these are really again a fundamental part of any program. But using these alone isn't always enough, and I'm going to show you an example. So let's say that we want to write a program where we query the user for a number, and then we want to display the absolute value of that number. And now in many mathematics, the absolute value of a number is like the value of a number without the sign, meaning that absolute value of minus 50 is 50, and then absolute value of 50 is also 50. So we just get rid of the sign and have the number alone. I guess you all remember that one. So let's do it this way. Let's say if number is more than 0, then we convert the number to its negative value, and then we can display that the absolute value is and number, and then we can check that if number is larger than 0, then we can just display that the absolute, if I can type it, value is number. So if I take a quick look at this one, it seems to be sort of reasonable code. So we first check that if number is more than 0, if it is, then we convert the number to its what is the word? Well, the negative value of the number. The complement is the word I think I'm looking here. And then we display that the absolute value is number. If the number is larger than 0, then we just display that the absolute value is number. So let's try this. And let's first start with something like a positive value like 150, and it displays that the absolute value is 150. Okay, it seems to be working fine. What happens if I give it a negative value? Let's see, minus 150. And now it displays the absolute value is 152 times. Why? What is the reason for this one? Please all think about this one. Yeah, that's a good question. What if number is 0? Let's get back to that in a second. But yeah, exactly. So both if statements are now true. So in this case, although we have different conditions in these expressions, in the first one we check if the number is smaller than 0, and in the second one we check if the number is larger than 0. What happens is that we change the value of variable number inside this first block. So when we get the second if statement, the value of number has changed, and now we display both of these. And that's probably not what we want. There are ways we could fix this program. Sort of, for example, we could assign the negative value in this print statement instead of changing the variable value, which would fix this. But if we actually need to change the value, let's say that we need to do something with the value in the program, and we need the absolute value for some reason, we want to calculate something or something like that, then this is sort of problematic. And for this reason, we're going to expand our if statement. and we're going to talk about, or going to have a new statement called the else statement. And the idea of the else statement is that we can define a block that's executed if the original condition is false. So if you look at this graph in here, what it displays is that we start by evaluating the expression. If it's true, we execute the first block. If it's false, we execute the second block. And then after that one, the program execution continues. And this if and else statement together form a conditional statement. I can't really see the graph because the chat window is on top of it, but I think that's what it is. Yeah. So the idea for the conditional statement where we have the if and else statements is that exactly one of these blocks is executed every time, regardless of what is the result of the expression. So it isn't possible that both blocks are executed, and it isn't possible that neither of the blocks are executed, but in each case, one of these blocks is executed. So we can change the program. So instead of having a second consecutive if statement, let's have an else statement there. And now how we should read this is that if this condition number is more than 0 is true, then we execute this block in lines 4 and 5. If this condition is false, then we execute the block at line 8. And now if we try this one again, let's try it with the positive value first. It displays that the absolute value is 150. And if we do it again with negative value, minus 150, it only displays one message stating that the absolute value is 150. And I think in this case, this is a better option because the value is either positive or negative. But let's get to, we had an excellent question before. What if the number is 0? What if the number is 0? Which block is executed?
The else block, because if the number is less than 0, that means that if the number is 0, then the first condition is not satisfied. So we use the else block. The program uses the else.
Yeah, exactly. So the condition here is that number is less than 0, number is more than 0, and 0 is not less than 0. It will display that the absolute value of 0 is 0, which is actually true. So it doesn't really matter in this case. In some cases, it might actually matter. Question, what is the terminal you are writing in, as in why not write in where you are writing the code? No, I don't really. If you mean this terminal window, this is where the program is actually executed. So we have a separate window for where we edit the program code, and then we have a separate window where the program is, or which displays the result of the execution. That's actually quite typical, and those are two different things, and that's why they are separated in different windows. There are a lot of other things you can display in here, like the debug console and things like that. But in this case, this is probably the most convenient one. Okay, let's change this program a bit. Let's say that we want to determine if a number is a positive number or a negative number. And then now we can use the else statement, which we found out quite convenient. And so it's a simple program. Again, we have just a simple conditional expression where we find out if the number is larger than 0 and output it's a positive number if it is, and if this condition is false, then we execute, or the Python executes the else block where we display that it's a negative number. So let's test it first. So 10 is a positive number and minus 10 is a negative number. So it's basically like the program we had before, but it's a bit simpler. But what I'm stating here, again, what about 0? What does the program output if I type in a 0?
It will give it as a negative number.
It will, yeah. Okay, so we can try it out. So let's display our answer 0, and now displays it's a negative number. And now it seems that these two options now can't cover all the possible outcomes we want to have. So we typically don't consider 0 as a positive or negative number, but it's like a third option. So we have negative numbers and positive numbers, and then 0 is something in between them. It's not positive, it's not negative, although we can talk about the positive or negative 0, but the 0 itself, it's not neither. Or it is neither, not either, yeah, something like that. So what we want to have is a sort of a third option for this conditional statement. And for that one, we're going to need yet another statement. And that statement is called elif. And the idea of elif, it's shortened for else if, is that if the first condition was false, we can test another condition like this. Now this one works already. We don't need to add anything to this one, but it still doesn't cover 0 as an option. And what we can do is, well, we could write another elif, something like elif number equals 0. This would work, but we can also include an else statement after the elif statement, or after the if and elif statements. And now the idea is that if this first condition is false, or if it's true, we execute the first block, and then let's have something like this. So if this condition is true, then we execute the first block, then output done. Well, let's test it first. It's easy like that way. For 10, it's a positive number, -8 is a negative number, and for 0 displays it's a 0 and then done. So in each case, again, exactly one of these blocks is executed. Not more than one, exactly one. So regardless of what was the result of the expression in here, or regardless of what was the value of number in this case, it's always going to be exactly one of these blocks which is executed, which is actually quite logical because the number is a positive number, a negative number, or a 0. And then after that, the execution continues after this one. There was a question, why not use larger than or equal, or smaller than or equal for this one? Because we don't typically consider 0 as a positive or negative number. And if I change this something like this, then the else block is never executed, and because 0 is considered a positive number in this case. But we don't really want to do this in this case. Again, that's a good question, because it's always important to really consider that whether what you're doing with these sort of like special cases. And I guess we can consider 0 as a special case in this one. And sort of cases like this are easy to forget. So you might be, I mean, if you're doing something with positive and negative numbers, it's easy to forget that there's a 0 in between, which is neither, and which you need to consider, because it's possible that the user types in 0 as the value, and then you need to do something with the 0. There was another question. What's the difference between elif and else? It's also an excellent question. Elif is shortened for else if, and the difference is that for elif you need to provide a condition. So this reads in a sense that if this first expression, conditional expression, if this first condition here is false, then Python check this second condition here. So it's like, okay, that one was false. How about this one? And then else is something that's executed after all the previous conditions were false. We can have any number of elif conditions, and it doesn't need to. We don't need to have the else statement after all these elif statements. And we can also, of course, have an else statement without having any elif statements. But we can't have elif or else statements without if statement before them. So both elif and else can only be used after an if statement. I also have a... No, I don't. Well, in material, there's also this graph about the elif statement, but I don't know whether that make things easier or maybe more difficult to understand at this point. Okay, let's see something else. So as I said, we can have a bunch of elif statements. Let's query for a name in this case. And now let's see that we want to check if the given name is... what do we want to check? Check for Donald Duck's nephews. Want to copy this one. See if I can remember how to spell all these names. Missing some here. Hopefully like that. Oh, we're missing a... This is actually that's sort of lucky error. This is sort of a typical error when, especially when you start programming at first, that you don't remember that there's a distinction distinction between using one equals character and two equals characters. And one equals character in Python is reserved for assigning values to variables, and two is reserved for comparing values. Now, question: why do you think it's like that? Why do we use one character for assigning values and two of these to compare values? Yeah, it's a syntax thing, but why do you think? Yeah, it's also to help separate them. You're absolutely right. But there's one thing. What I'm sort of looking for here is that why was the choice made to do it like that? Why do we use one for assigning and two for comparison? What do you think? I mean, I'm not sure about the reason, but I think and I think the reason it's actually, well, there are actually a lot of reasons probably, and one of them is that it's used like this in other programming languages as well, which makes it easier to adapt to new languages. But yeah, definitely, exactly. The one what I'm looking for, what I think is that assigning is used more. So if you're doing a program, you're typically assigning a lot of values, and I mean, comparing values is sort of typical, but it's not as common as assigning values. So I think that might be one of the reasons, sort of. So let's try this program first. It's always a good idea when you're done writing program, always see if it works. So let's try these names. Yeah, that one works. Do we also works? And let's see if Louis works. Yeah, it doesn't. Then if we provide something else like Mickey Mouse, then it says you're probably not Donald's nephew. So the thing about here is again that now we have two elif statements. So we have four possible outcomes for this program, although three appear to be sort of similar, and we get back to this in a minute. But we check if the name is Hui. If it isn't, then we go to second condition. We check if the name is Dewey. If it isn't that one either, we go to third one, check if the name is Louis. And if it isn't that, then the else statement is executed. So the else statement is again executed only if all of these three conditions before were false. And now this question, what would be the difference if we replace the elif with all if and then the last one remain else? In this case, it isn't that big. We could have separate sort of if statements for this one as well. Actually, there is a difference. Sorry, what is the difference? Now, this was again, you have very, very good questions starting from the beginning. I really, really liked it. Please go ahead ask away whenever you have anything you want to. What is the difference with this one? This is actually a bit more. Let's try it. So the else only works for last if. So if I provide Louis, it states that you're Donald Duck's nephew. If I provide something like Mickey Mouse, it displays you're probably not Donald Duck's nephew. What if I provide a name like, what if I provide Hui? What does it output? And this is now the difference. It outputs that you're Donald Duck's nephew and you're probably not Donald's nephew. Why? Why two outputs? Yeah, yeah. The else is under the only if. So the else is now connected to this if here, meaning that if this condition is false, if the name isn't Louis, then it outputs that you're probably not Donald's nephew. And in this case, we don't want to do it. We want to connect all these if and elif statements. Uh, so so that the outcome is one of these four possible outcomes, but never more than one. And we can do that by creating one single conditional statement with where we have one if in the beginning and then some elifs and then else as the final one. There was also a question, could you put else before elif or is it always elif? Then it's elif and then else. Else needs to be like the final block of each conditional statement. And that's also sort of logical, but because else is like, okay, we covered all the other conditions and none of them was true. So let's then execute this else block. So else is something we do if everything else fails, kind of thing. Nothing was true before that, so let's just do the else part. Okay, if you take a look at this code now, it seems to be working after fixing it back to its original form, so we can check for Donald's nephews like this. But you see that there's some redundancy in this code. We have this same output 3 times. And whenever you're repeating something in programming, it's a good idea to stop and think whether you can do it in some other way. At the moment, we don't really have all the tools needed to do all things that way, but in a lot of occasions, it's possible to sort of not, or it's possible that you don't need to copy and paste the code. You just need to, you can use the same code over and over again. And so what we can do in this case is use something called logical operators and join some conditions. So let's combine these conditions into a single conditional expression by using something called a logical operator, and in this case the operator we're using is OR. And the idea is that we can now, with a single expression, we can check if the name is Huey, or if the name is Dewey, or if the name is Louis. And if one of these is true, and more than one cannot be true in this case, because name can only have one value, name variable. If one of these is true, then this block is executed. And if none of these is true, then the else part is executed. So this is sort of convenient. Let's try it. Let's not just trust my code. That works, and that works, and that one works as well. And then let's try something else. And for Goofy, it says that you're probably not Donald's nephew. So it seems to be working. At least for all of these sort of logical test cases. So we can combine several expressions into a single expression by using the logical operators. And the idea of the OR operator is that the whole expression is true if one of these sort of sub-expressions is true. So if one of these expressions we joined with this OR operator is true, then the entire expression is true. We could use it for something, or actually a lot of things, and it's quite useful. Let's do something. There isn't. That's a good question. Is there a limit to how many OR operators you can have in a, well, not in a string, but in a statement or in an expression? There really, I don't think there is. But I'm saying that if you have more than, let's say, 5 or 6, then you probably want to simplify your program a little bit, because it can get really difficult to comprehend. But I don't think Python sets any limits. There probably some kind of practical limit on based on memory or something like that, or that, I don't know if there's a limit for the length of a single expression in Python, but anyway, if there is, it's going to be like tens of thousands of characters, so it doesn't really matter. So there's a sort of a practical limit in a sense that you don't want to have a too big of an expression, because it's really difficult to comprehend and difficult to fix and difficult to debug, but Python doesn't really limit it in any sense, or any sense that matters. Okay, let's go into the user for the age. And then let's say that we only want to allow, or we are only, for some reason, in our program, we are considering people between ages, let's see, 18 and 63. So we can check this stating that if age is larger than equal, or no, let's not do it like that. Age is more than 18 or age is larger than 63, then let's say that you can apply for this job for some reason, and else, and you can apply here's the form, and then so on. So we can use the OR operator for a lot of things, and one of sort of typical thing is to find out if the value is not between the limit we are looking for, or not within the limit we are looking for. So this one only accepts now this program only accepts the values which are between 18 and 63. There's another way of doing this which might be more logical, and it's the AND operator. And the idea of an AND operator is that, again, we can combine several expressions into a single expression, but now all of those sub-expressions need to be true so that the whole expression is true. So we can change this stating that if age is larger than or equal to 18 and the age is smaller than or equal to 63, and then we just need to switch these outcomes like this. There's a question I'm curious, is it possible to insert a form into Python, or would it be a different you can do forms in Python, you can do web programming in Python. There's for example, a framework called Django, which is, it's like DJANGO, which is a really convenient in writing web programs. So doing web programming with Python, and then you can do forms with that one as well. We're not going to talk about that in this course or in advanced course, but also the idea is that after completing both these courses, you can sort of learn these different frameworks quite easily yourselves. Django isn't that complicated, and there are a lot of good tutorials in the internet. It's a good question again. Okay, let's try this out. So if I provide an age between 18 and 63, like 33, it says you can apply. Let's give something too young, like 16. It says you can't, and something too old, for this case 66. It says again that you can't. So we can easily use the AND operator as well to perform sort of a similar check that we did before with OR operators. Now, which one you want to use, it sort of depends on what you're trying to accomplish. And I say in this case, this AND operator thing is probably more convenient because I think it's more logical to check whether you are of given age than checking whether you are not, or not given age, but required age. Both work, but I think it's also important that you think that how your program is as logical and as easy to understand as possible. There's also a not operator. Talk about that in a minute. But here's this table which might sort of clarify how and or operators work. So the idea is that there are two conditions in here, A and B, and all possible combinations of false and true. And now you can see here in this third column that A and B is true only if both A and B are true. So only true and true becomes true. But with OR operator, A and B are false only if both are false. And operator it's really easy because it's I think it might be easier to understand because it's similar to like a natural language counterpart. So if you have a sentence like a ball is red and it's on the table, that whole sentence is true only if the ball is red and it's on the table. If the ball is of another color, if the ball is blue or red or sorry, green or something, or if the ball is not on the table, then the whole sentence becomes untrue or false. And for or statement, if at least one of the expressions combined with or is true, then the whole statement is true, or whole expression, sorry. Not is a little bit, it's actually sort of easy in a sense to understand that what it does, it complements the Boolean value. So false becomes true and true becomes false. And now let's talk about these Boolean values a bit. So whenever we are doing a conditional expression like this one, all these all these parts become true or false, and finally the whole expression becomes true or false. Now this question, is it possible to change the not operator with other operators? Yeah, it is. You can do something like if not age is larger than or equal to 12, but please don't do this. I mean, this is definitely more difficult to reach than stating that if age is smaller than 18. But there are some occasions when using not is a good thing. I'm going to show you, I'll try to show you something like that in a minute. Also, there's a question, is it possible in Python to change the colors and the program would pick up on the color code? If you're doing some graphical programming in Python, then you can mess with the colors. We're going to talk about a library called Pygame at the end of advanced course, and there we also talk about switching colors and things like that. If you're talking about this terminal here, then if you want to change the color of this one, you can't really do it with Python. Or, well, not with Python alone, at least. You can probably change it in the settings of this Visual Studio Code. Anyway, so Boolean values of true and false are values in Python, like all the other values, like numbers and strings and things like that. And we can assign a value like that in the variable. We can say that truth equals true, like this. And after this one, we can use this as a condition. So let's do it like this. So what does the program output? This one should be rather simple. So what will the program output? Will it output it's true or it's not true? Yeah, it outputs it's true because we assign the value of true in the variable truth, and then we check for that one. And this is a valid condition. And it's valid condition because whenever we have a conditional expression in Python, it evaluates to true or false. And now it's important to remember that when we are using this conditional or these Boolean values, you need to write them with capital T or capital F, so it's true or false. If we change this to false, then of course it outputs that it's not true, because now this condition becomes false. You can create these Boolean variables like this as well, because as I said, any conditional expression in Python evaluates into true or false. So what happens here is that Python evaluates this expression, and then the result is assigned into this variable. So what will it output? True or false? Let's see, it outputs it's true because 4 is larger than 2, and 4 is larger than 2 is true, so true is assigned into truth. You can also output or print the Boolean variable like any variable, so it just outputs true over there, which is the value of that one. And this question, how is that possible if we do not enter any value that it automatically brings true? It automatically brings true because any conditional expression is either true or false. So we can assign those values. You can write something like this. And now if you do something like this, you can see that what happens in the editor is that this is a little bit darker shade now, and the reason is that this code block is never executed. And it does so there's this pylance which checks for the code styles, and it says that the code is unreachable, and the reason that the code is unreachable is because true is always true, and that's why this first block is always executed. Okay, let's change this to truth, and then let's do this. What will the program output now? True or not true?
It's true.
Is it true? Think about it. What happens in here? Now this, I'm sort of overcomplicating things a little bit, but I think I'm doing this because I want you to understand what's happening in these conditional expressions. The fact that whenever you're comparing something, then that becomes either true or false, and that is the one you're using in conditional expressions. It's not true, of course, because now we assign a value of true in the variable truth, and then the not operator changes the value to its complement. So true becomes false, and false becomes true. So because this is true to begin with, then it becomes false. We can also see this if we output it. Let's output it here. And then let's output it again in here. Getting rid of all this code in here. So now you can see that it first outputs true, and then when we change it to not true, then it outputs false. So not operator is like a minus for integer. It changes the value to a logical value to its complement. Or Boolean value, like we call them in programming, to its complement. So Boolean variable only has two possible values, true or false. Okay, we will talk about this more later, but typically we just type the conditions themselves. So we type something like is 6 is larger than 3, or we usually use variables instead of doing something like t equals 6 is larger than 3, and then if t, but this is exactly equivalent to one before. How do we know if variable is Boolean? We're going to talk about variable type more, but you can use the type function in Python to determine the type of any variable. So it basically output class bool in this case. We're going to talk about these types more in I think in week 4 or 5, and about determining the type as well, because that's really important. That's a really good question, because there are a lot of occasions where we might not be sure about the type of the variable, and we need to check this. And that's also true for occasions like whether you have an integer number or a floating point number, and because we already seen that the outcome of expression might be different if one of the values is a floating point number. But we're going to talk about that a bit later. Okay, in Python, it's also possible to chain conditions like this. And this is probably more. So let's read the 8s again. Let me have it somewhere in the. And let's see that if. You can apply and so on. So we can combine, as we talked about before, we can combine conditional expressions like this. And now it's important that whenever we are combining, that we are combining complete expressions. So I sometimes, so something like this isn't a valid Python expression. If you want to know if the age is 10 or 20, you need to type in that if the age is equal to 10 or age is equal to 20. So you can only combine complete conditions. So although this might appear like a logical thing in a natural language or something like that, Python doesn't understand what you're doing here. So you need to do it like this. But when you're checking if for example, is a number is a between or in a certain limit or between other two values, we can change these operators or conditions, and we can write something like 18 smaller than 8 smaller than 63. And this one works. So we're basically chaining two conditions into a single condition, stating that age must be between 18 and 63. And if you want to have also include 18 and 63, then we can change these two smaller than or equal these operators. So let's try this out. Let's give something like 44. I can apply, but something like 15, it doesn't output anything, or something like 65 doesn't output anything. So something like this is convenient, especially in the cases where you're looking for value that's between two other values. This doesn't work in a lot of other programming languages, and for that reason, for example, I'm not really convenient in using it. I'm sort of typing it with two separate conditions. There's also I don't know whether I should talk about this at this point. Well, maybe I can show you an example. Because we talked about conditional expressions as well. You sometimes see a code like this, especially later in the course. Let's say that we're in the restaurant door and we want to determine if the person is 18 or older. Now, what happens here? Can you explain this one in your own words? Or I mean, there's no point in doing this, but you sometimes see a code like this, and this is problematic in Python. Let's try it out. So let's say that I give 16 as age, it doesn't output anything. I give 24 as my age, and it still doesn't output anything. So what, especially when we talk about other operators like in operator next week and things like that, then you sometimes see conditional expressions like this. And of course, this checking if this is true is redundant. We don't need to do it because this conditional expression already becomes true or false. Yeah, exactly. like you wrote in the chat window, it's unnecessary. But it also doesn't work. You might think that what happens here is that Python evaluates if age is larger than 18, which becomes true or false, and then compares it to true. And that would be sort of the logical thing, but it doesn't happen here. What happens here is the same thing that happens in this one. So this is not program code. I'm just saying that Python rearranges this into two separate conditions, like 18 smaller than 18 smaller than 8 and 8 smaller than 63. So this is what Python does when you chain these operators. And the same happens in this one, actually. So 8 is larger than 18 equals true, actually becomes 8 is larger than 18 and 18 equals true. And this is why this is always false. 18 is not equal to true. True is a Boolean value. 18 is an integer. They are of different type. They can't be equal. And they are not same value. So the reason, again, I may be overcomplicating things a bit, but reason that I want to talk or wanted to show this one is that it's possible that you do make this kind of error, especially with some other operators, probably not with these comparison operators, but so on. And this might be a really difficult error to find in a program. Hopefully someone may remember this at some point and so on. It's a really Python specific thing, but chaining operators, as I said, something like this is, I think this is a good way to check if the age is between 18 and 64, for example, or some whatever, whenever you are trying to find out if the value is between two other values. Then a little bit about nested conditions. I think we can do the same example. So let's say that we want to find out well, actually, let's get back to this one first. So we have the age, and let's say that we want to check if the person is older than 18 so that they can apply for the job. But then, well, let's do that first. If 18, age, and if the age is 18, between 18 and 64, but then let's say that the persons of different ages can apply for different kind of roles. So we can check then that if age is larger than 15, then you can apply for a senior role. Let's not hope that this actually happens anyway, but and so on and so on. So we can nest these conditional statements. So you can have conditional statements inside other conditional statements. And again, you can nest them as much as you want to. Something like this. So now, in these kind of cases, it's really important that you pay attention to this indentation of the code. So now this else belongs to this if here, and this else belongs to this if here. And in code editors, there are usually these lines or some kind of other indicators stating that which ones belong together. So you can see that if it's visible in the Zoom, that there's this small line from if to else in here, stating that these belong together, and between these if and else statements here. And what happens in this program is that we first check if the age is between 18 and 63, and if it is, we display that you can apply, and then we check again if age is larger than 50, so it must be 50 and 63 at this point, and then we, based on that, display a message stating that you can apply for a senior or junior role or something like that. And oh yeah, it's true. Thanks. Yeah. And if the age is smaller than 18 or larger than 63, then it doesn't execute this block at all. So then it doesn't do this comparison at all, this if the age is larger than 50. So we can try it out first. So let's give something like 16, so that you can't apply. If you are if older than 18 and younger than 63, something like 44, it said you can apply, and then you can apply for your junior role, and let's say you're 55, you can apply, and you can apply for senior role. So often it's convenient that we can first test for something, and then if something is true or false, we can test for something else, like in this case. And this is typically how we build our programs, that there are sort of these paths where the program goes depending on some conditions, and then we execute some other maybe tests, and then the program again, the execution is divided into separate paths and so on. Let's see another example about this one. Let's say that we query for a number, and we want to find out if the number is an odd or an even number. And typically we only consider positive numbers to be odd or even. And negative numbers are not odd or even number, typically in mathematics at least. So let's say that we first check if the number is larger than 0. Then we can check that if the number is an odd number. We're going to talk about this modulo operator in a second. Even number, and then else. Again, we could do this differently. We could have like if and else statements in here to detect negative numbers, or however you want to. So and it's really typical that when we're doing this rather simple programs, there are typically several ways on how you can implement a program. You can use different techniques. You can use nested conditional statements, or you can use the and or operator. So you can use elif and else statements, or you can combine these and so on. Typically, some solutions might be more simple, but then again, you might prefer one way to others or something like that. Yeah, we could include 0 as well. 0, or it sort of depends. 0 in some sense is considered an even number, but then again, 0 is also 0. You can say that 0 or negative number. And the percentage operator, that was something I promised to explain to you in a minute. So let's test this first. Test it first. I mentioned testing programs is important. 20 is an even number. 15 is an odd number, and then minus 88 is a 0 or negative number. So it seems to be working, at least for that one. The percentage, it's a modulo operator. So what it does, it gives you the remainder of a division. So 5 modulo 2 gives you the result, the remainder of the division 5 divided by 2. So 5 divided by 2 is 2, and then the remainder is 1, and so it outputs the 1, which is the remainder. And the modulo operator is great when you want to see if a number is divisible by another number. So let's get the program back now. Over here. So in this case, because we use the modulo operator with number 2, and we check if the remainder is 0. And if the remainder is 0, it means that the number provided is divisible by 2. So it must be an even number. If the remainder is not 0, then it must be 1. And that means the number is an odd number. Because it's an integer, the remainder is always either 0 or 1. The modulo operator is useful for whenever we try to find that the number is divisible by something. It's useful in programming in some other ways as well, which we're going to talk about a lot later, actually. But finding out if if a number is an even or odd number is really a useful thing. There are a lot of occasions where we want to do something different to odd items and even items. If you think about graphic stuff again, for example, it's quite typical that when you display a table, then for every other line is of a different color, so it's easier to read that one, and that can be done easily by checking whether it's an odd line number or an even line number. So we will be using this model operator quite a lot. Maybe you can actually test it out a little bit to see yourself how it works, but it is quite convenient. And the most typical way to use it is, I would say, that to find out if a number is an odd number or an even number, but you can use it to test for basically for any divisibility. Okay, the same example is here. Then the final thing for today is it's about repetition. Let's take this one in here. And we start with a simple repetition statement, a simple loop. It's called a while loop. And the thing I talked about in the first lecture was that loops are basically what makes programming so useful. The idea that we can perform the same operation over and over again is what makes programs so efficient, and it's sort of the reason why we're writing this. We can do it the same operation for example for all characters in a long string, or for all numbers somewhere, or for all lines in a text, or whatever we want to do. And today we start with these simple examples on how we can keep repeating the same thing over and over again until we want to stop repeating. And it's usually typical that when we have a loop, it needs to end at some point. It needs to terminate at some point. And let's have something really simple first. Let's query the user for a number again. And then let's just display the number times 2. Number times 2. Now you don't need to use the parentheses around this number times 2, but I like to do it because it sort of separates the expression from the string here. And now, when we have this while statement with true condition, then it keeps on executing this over and over again. Meaning that let's start the code. And then it asks me to give a number. If number times 10 is 20. And now it keeps on doing this until at some point I'm going to terminate this one. I can start it again if I want to. But there's no way to end this program except terminating this Python process, this Python debugging process in here. And that's why usually when we are writing these loops, we want to provide a terminating condition to user, something like -1 stops. Let's say that 0 stops because you don't want to use you don't want to know what's it. And then we can check that if the number given was 0, then we can break out of the loop. So the break is the statement that ends the while loop, and then the condition, or sorry, the execution continues after the loop. So now when we execute this again, you see that it works. And now when I provide 0, then it stops the execution. And this is basically how we start learning the loops. This is all we're going to do with loops this week. It's like the final thing. So we can keep on repeating a certain code. So let's say that we want to modify this program again by providing the possibility for user to check for several values one at a time. So we executed it, and then we can test for values. 24 is even, 23 is odd, 9 is odd. negative numbers are not supported, and then 0 stops the execution. So we just check that if the value provided for user was something that we don't want to process or something the user can give, and then we terminate the loop and terminate, and then the program execution continues after the loop. So this is basically what we're doing with loops this week. Next week, we're going to continue from this one. So basically, well, yeah. And next week, we're going to talk about more loops. We're going to talk about having conditions in loops and how we can use that to, for example, to iterate through certain values or things like that. And then we're going to talk about string operations. So now we've been using strings. We've been, for example, reading user's name or something like that. But there's a lot we can do with the strings in Python. We can slice them up and we can pick individual characters from a string. We can look for the occasions of substrings in the strings and all that kind of things. And then we're going to start talking about own simple functions next week. There was a question, is it possible to send this recording to the Discord channel too? Yes, if I remember to do that. But I mean, you can quite easily access the recording in the materials. It's on the front page of the material. So if I remember, I can paste it to Discord channel. If someone else can also do that, if you remember. It takes a while to process this, and that's why I need to do some stuff after this one as well. So I'm not promising, but I try to remember. Any questions about the stuff this week? So the main things for this week were the elif and else statements, meaning that now we have more flexible and can have more flexible and more complex conditional statements. Then there are the logical operators and, or, and not, which we can use to combine expressions into more complex expression. And then there are the nested if statements, which are useful when we first want to check something and then check something else and so on. And finally, the simple loop for repeating stuff over and over again. Any questions about these? Remember that you can always keep on asking on Discord. You can send messages to me, or you can ask in the public channel. You can send email if you want to. And yeah, I think maybe we're done with this one.